This video is an excerpt from the ϕPPL Programming Language Lecture Series. Copyright 2013, Technoventure Incorporated. Enumerations. This segment makes use of the syntax specifications covered in the lecture on basic declarations. Please review that video if you need a refresher on syntax notation. As in popular scalar programming languages, the ϕPPL has a handy way of creating a series of symbol names equated to a set of serialized scalar values. These are called enumerations. Their names are constructed from the 254 characters allowed in identifiers. The first character must be alphabetic. As with equates, enumerated symbols along with their types and values are only in existence during compile time. Because they are not allocated storage in the target application, you cannot take their addresses. This is the difference between an equate and a constant in phi. Constants are like variables in that they occupy space in the target's application memory, but equates do not. Unlike Pascal and Java, an enumeration declaration in phi does not actually create a new type. And unlike C and C++, the type of enumerated symbols is not predefined for you. Rather, in phi, the programmer must specify the type for the symbols being created. The syntax for an enumeration has this form. The keyword enu begins all enumeration declarations. The type of the symbols being created comes next, followed by a colon. An optional group name comes next. When a group name is not used, each name that is created will be referenced alone. Also, when a group name is not present, the enumeration symbol list must be complete. When a group name is specified, a namespace is created. All of the symbols are created under the common high-order group name. When later referenced in a program statement, the group name by itself is treated as a qualified synonym for the enumeration's type name. To reference one of its values, write the group name first, then a dot followed by the specific name. Next in our specification is the optional step. If an explicit step is missing, it is assumed to be +1. The explicit step starts with one of the operators plus, minus, multiply, or divide, shift left or right, or rotate left or right. Following this is the increment for plus or minus, scalar for multiply or divide, or the count for the shift and rotate operators. The step value must be known at parse time. The list of symbol names comes next. It is enclosed in set braces, which are the ASCII curly braces as shown. Individual names are separated by either a comma or a solid vertical bar. Here the solid vertical bar is used as an alternative OR. When a name is followed by one of these, the next name will take on the same value as the previous one unless it is explicitly assigned its own value. When a name is followed by a comma, the following name will take on a value after being modified by the step operation unless it is explicitly assigned its own value. If the name is assigned its own value, this happens after the step operation from a preceding comma or before the step operation from a following comma. The temporary initialization variable used to initialize subsequent symbols takes on the new value as well as the current symbol. In enumerations with a group name, this temporary initialization variable becomes semi-permanent as it persists throughout compilation. In enumerations without a group name, the temporary initialization variable goes away when the enumeration declaration is complete. Finally, the semicolon at the end of the declaration is optional. When a group name is specified, a trailing separator at the end of the symbol list keeps the group open to support enumerations that are incrementally declared across multiple enumeration declarations. The type and step must match in all enumeration declarations for any one group. The absence of a trailing comma or solid vertical bar at the end of the symbol list closes the group, and no more symbols can be added to the enumeration. When an enumeration is first created, the initial value can be explicitly set by an assignment to the first symbol in the identifier list. If it is not assigned an explicit value, then the initial value is implied by the step operator. A plus or minus step operator sets the initial value to 0. A multiply or divide step operator sets the initial value to 1. A shift left sets the initial value's low order bit to 1 and clears all other bits. A shift right step operator sets the initial value's high order bit to 1 and clears all other bits. A rotate left step operator clears the initial value's low order bit to 0 and sets all other bits to 1s. A rotate right step operator clears the initial value's high order bit to 0 and sets all other bits to 1s. When an enumeration declaration is parsed, a temporary initialization variable is created of the type that is in the declaration. It is initialized to 0 when the step operator is plus or minus. Each name can optionally be assigned a value which overwrites the temporary initialization variable with a new value before being assigned to the symbol. If a name with its optional assignment is followed by a comma, the step is applied to the temporary initialization variable after assignment. Otherwise, if a name is followed by a solid vertical bar, the step will not be applied, and the next symbol to be defined will take on the same value. Now let's look at some examples. In this first example, we will create a number of values that have names of fruits. Their shared common type is an unsigned single byte type US. No group name or step is specified. After the declaration is parsed, the following symbols will be created. For our second example, we specify type SD and the group name car. We specify an increment of +2 and a list of model names. We then end up with the following symbols and their values. Notice here that the first symbol has a value of 6 because it was explicitly initialized as such. Each subsequent value is 2 greater than its predecessor because an increment of +2 is specified in the step. When you want to reference a symbol, include the group name if it was declared with 1. When you declare a variable with a type that was defined as an enumeration group name, you can then use it in a switch or branch control structure and dispense with the group name in each of the cases. In this third example, we will create a collection of masks that can be used to set or clear bits representing 4 visual attributes of a character using bitwise logical operations. This concludes our discussion of enumerations in the ϕPPL programming language.